Hey everyone, today we're doing increasing triplet subsequence. This is a problem in LeetCode 75. 5 problems that you ideally want to do before you start applying for jobs. This problem number 334, it's an array type of problem. Given an integer array nums, return true if there exists a triple of indices I, j, k, such that I is less than j is less than k, and nums of I is less than nums of j is less than nums of k. If no such indices exist, return false. So the important thing to know here, and it would be clarified in this second or the third example, is that we have the numbers 2, 1, 5, 0, 4, 6. Now, it doesn't matter. It's not strictly consecutive. For instance, it had to be I, j, k all had to be like one apart. We could just loop through every pair of 3 integers and see if we ever find an increasing subsequence, right? But here we're just saying if there's any set of 3 where we have the indices to be I less than j less than k, and also nums of I to be less than nums of j to be less than nums of k strictly. So in this example, we see, all right, we're going to go here. We see 5, we see 6. That's one valid triplet, so we should ideally return true if there exists one. Is there anything else we see? We see 0, we see 4, we see 6. That's also a triplet. We see 1, we see 4, we see 6. It's also a triplet. Just a few different ideas of what triplets could be. They don't necessarily have to be consecutive. So to approach this problem, I would first set a few variables to hold the data that we currently know and the data that we're trying to find. I have some kind of variable called first, which is initially instantiated to infinity. This would just be our first smallest number. We want to find a triplet, right? So once we found those 3 numbers that satisfy the condition, we're done with our problem. And then we have a second, which is also infinity. We could have like a third, although like the moment we found the third, the moment we found that, we know that we're done, right? So the moment we get to this line, we don't even need a third in reality. So what we do here, or at least how I would approach this problem, is first I'd say if len of whatever array we're working with nums, we say that's less than 3, so automatically we cannot have a triplet, just say false, right? False. Otherwise, we go through our current index. We don't need a triple for loop to be solving this problem. It just seems incredibly excessive, and it's an O of n cubed runtime, which is just, for larger arrays is incredibly not useful. I'd say for I in range, or like for num in nums, I'm going to say this is less than first, make it the new first. The new first is num. Else, if it's less than second, make it the new second. Otherwise, if it's less than the first and it's less than the second, if it's not less than the first and it's not less than the second, just go ahead and return true. Because there we've officially found 3 numbers that are increasing. Let's run through it with this example, right? So first, we have 2. 2 would go and assign to first, because obviously 2 is less than infinity. 1 would now go and assign itself to first, because 1 is less than 2. We'd have 5, which would go and assign itself to second, because 5 is not less than our current first, which is 1, but 5 is less than infinity. So 5 would go there. 0 would assign itself to first because 0 is less than 1. So our new first would be 0. Sorry. And when we get to 4, 4 would replace our current second. So this would become our new second. And finally, when we get to 6, 6 is now not less than 0, not less than 4, and thus we return true. Because we officially found our third number that would satisfy our equation and show that we have increasing triplet subsequence. Outside this entire loop, if not, we just return false. If none of these conditions ever get satisfied, we return false, and we are done with our solutioning. Great. Let's go ahead and let's type this up so that we can finish this problem. Let's say if len of nums less than 3, we go ahead and return false. For num in nums, right? I'm going to go ahead first and define first equals infinity, second equals infinity. For num in nums, if num is less than our current first, go ahead and make first to be num. Also, if num is less than our current second, go ahead and make second to be num. The else if is really important here because we don't want both these statements to execute. We just want, that statement or that statement. Or if both of those are false, we go ahead and return true. Outside the loop, we go ahead and return false. And realistically, with only one for loop for the solution, one for loop implies solution runtime is O of n. Float object is not callable. Is that not how you do infinity? Is infinity just that? Sweet. Is this equals to? It's less than or equal to. Because otherwise, in cases like that, we have an infinite loop. Perfect. Great. Thank you guys for watching. Hopefully this video made sense. This is one of, if not the most optimal solutions for this problem. So if you like the content you guys watch, please do please do comment your thoughts and subscribe. Thank you guys for watching, and I will see you next time. Peace.